Okay, so in this problem, we're going to look at a question paper, January 2019. It's paper 1C. So I'm going to look at question number 3. This is a very common question that you do see this almost every year. So this is the first question is that name the industrial process used to separate crude oil, that is fractional distillation. So you would write this. So I'd like to talk about something. This is a distillating column. And you would have a heating source here. So when the crude oil vapor is coming in, that means that the crude oil was heated here, and the heated vapor is coming in. And as you move farther away from the heat source, it's gonna get colder up there. It's colder up there as you go up along the column. So what happens is you would have heavier stuff. Heavier stuff means stuff that has a very high boiling point. So they would be, you'd start collecting heavier stuff at the bottom, and as you go up, you would see that these are the lighter stuff. That means they have low boiling points. So that means they boil easily, so they stay as vapor most of the time. So that's the idea. You would have heavier stuff at the bottom. Butadiene is very heavy. You use it to construct roads and stuff, and as you go up, these are lighter compounds. These are lighter compounds. So just keep that in mind. So that's what you have to take from it. So the use of kerosene and a use for butadiene. So kerosene is mostly used as jet fuel, and also you can use it for cooking and stuff. So these are the common ones. And butadiene for road construction. So you should know these by now. So that's that. So a molecule of the hydrocarbon icosane has the formula this. Explain which homologous series isocane belongs to. So the way that we would look at it is that we know that alkanes, the general formula for alkanes are CnH2n plus 2. And that of alkenes are CnH2n. So we'll compare this. So this belongs to CnH2 times 20 plus 2. So we see that this is an alkane. So this belongs to the alkane homologous series. That's it. And whenever they're asking explain, and you see 2 points, you know that you just cannot say the answer is alkane and just walk away with 2 points. So when you state that it is an alkane, you get 1 point. And when you say that because of this general formula, because icosane meets this general formula, you get the second point. So you get 2 points that way. Name a catalyst used in the industrial cracking of isocane. So for industrial cracking, we look at basically 2 catalysts. One is silica, or you could say alumina. So this is for catalytic cracking, right? Just remember and recall that there is another form of cracking known as thermal cracking, right? You can do cracking without a catalyst, that is thermal cracking, and that happens between 450 degrees Celsius to 750 degrees Celsius at 70 atms of pressure. Just remember this, because you might come across a question that would ask about thermal cracking. So just remember that. So in this one, a cracking was done on isocane, and you have this, which is, if you look at it, you can see that the general formula here is CnH2n. So that means you have produced 3 moles of alkene. And which alkene? As it has 4 carbons, so you know that you have produced 3 moles of butene here, right? And so now the way to do this is, so you know that you have 1 molecule of another hydrocarbon. So that makes our life much easier. So there is no coefficient on this part. Okay. So the way you do it is you count the number of carbons. Here you have 20 carbons. Here you have 12 carbons. 3 times 4, that's 12 carbons. So I have 20 carbons here, and then I've already taken care of 12 carbons with the alkenes. So how many more carbons do I need on this side? I need 8 carbons, right? So I know that I would have an alkane with 8 carbons. So as it is an alkane, you would use CnH2n plus 2. So 2 times 8 is 16 plus 2 is 18. So this is the alkane you would produce. So just to be sure, you can calculate and see that whether the values are right or not. So you can see that you have 24 hydrogens on this side. 8 times 3, 24, and you have 18. When you add them up, you would end up with 42 hydrogens. And you have 12 carbons on this side, 8 carbons on this side. When you add the carbons up, you would get 20 carbons. So you're good. Okay. Hydrocarbons can be saturated or unsaturated. Explain what is meant by the term hydrocarbon. So again, you have 2 points here. So the first point is going to come from saying that these are stuff that contains carbon and hydrogen. And I have seen students just finish it up here, stuffs with carbon and hydrogen. Well, there are a lot of stuffs with carbon and hydrogen, but they are not hydrocarbons because they have other elements in them as well, other atoms as well. So the second point you have to say is these are compounds that have carbon and hydrogen only. Believe it or not, just saying this gives you the second point. State what is meant by a hydrocarbon being saturated. So alkanes are saturated. Saturated means basically you have the maximum number of different atoms attached to a carbon. So what do I mean by that? A carbon can have 4 bonds. So if it is bonding with 4 different atoms, it is saturated. But if it is not, say in this case, let's look at this carbon. Let's think about these carbons, right? It has double bonds. So you see that a carbon can bond with 4 different atoms. But in this case, this carbon, is just bonding with 3 atoms, right? It's bonding with this carbon, it's bonding with this hydrogen and this hydrogen. So it is not like it did not bond with the maximum number of different atoms. So this guy is unsaturated. And this guy is saturated. So what do we mean by that? What do we mean by hydrocarbon being saturated? It means that the hydrocarbon contains carbon-carbon single bonds only. Because you cannot have anywhere where it has carbon-carbon double bonds. Describe a chemical test used to distinguish between unsaturated and saturated hydrocarbons. So there are 2 different tests you can do. You can add bromine water, or you can use potassium manganate. Okay, so it has 3 points, so you get 1 point for mentioning each one of them. And then the result. For bromine water, what happens is the color changes from orange to colorless for alkenes. And for this guy, the color changes from purple to colorless for alkenes. So saying this, either of these 2 is going to get you the second point. And the third is stays orange for alkane. And this guy stays purple for alkanes. This is the third point you get. So you can't say that use bromine water and the observation is purple to colorless. Then no, that is wrong. So all you have to do is you can say either one of these. So this is going to be your first point, second point, third point. Okay. The unsaturated hydrocarbon C4H8 has several isomers. The displayed formula, and the displayed formula is basically when you show every single bond. You cannot just say show one and do not show the others. That's not going to work. You have to show every single bond. That's one of the common mistakes that happens. Okay, so we have to name this isomer. So first of all, we're going to count the number of carbons. We see that 1, 2, 3, 4. There are 4 carbons. So I know that it's going to start with bute. I know it's something to do with bute. But there's a double bond. And the way this works is we're always going to count from the side that'll give the double bond less, how do I say it? The least number, which means a higher priority. If I count from here, 1, 2, 3, 4, the double bond is on the third carbon. So we're not going to do that. So we're going to count from here, 1, 2, 3, 4. Now the double bond is close to the first carbon. So that's the rule. That's one of the rules of naming. So this is going to be butene, right? I know that this is going to be butene because of the double bond here. The end is going to be in. But where is the double bond? The position is on the first carbon. So it's going to be but-1-ene. That's the name. And remember that between numbers and letters, we use dashes in the IUPAC naming system. So this is but-1-ene, right? So now draw the displayed formula of another isomer of C4H8. So there are a lot of stuff you can do. So you can just move the double bond to a different place. So now notice that they ask for a displayed formula. So don't forget about that. Don't do that mistake. All right, I'm just gonna grab a different color. All right, let's do this. Okay. So the first trick is I can just move the double bond here to the second one. So in that case, what I would have is now, as this carbon has already 2 bonds and I'm going to draw a double bond, I cannot have any other hydrogen because the maximum number of bonds a hydrocarbon forms is 4. So this is one isomer. To be sure, just count the number of carbons and hydrogens. Over here I have 4 carbons, here I have 4 carbons. Here I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Here I have 1, 2, 3, 4, 5, 6, 7, 8. So I'm good. This is right. What is the name of this? This is definitely, if I count from here 1, 2, the double bond is in second carbon. This is good. If I count from here 1, 2, it doesn't matter where I count from. The name is but-2- I'm sorry, this is butene. Right. So I can do another thing as well. What I can do is I can do a branching. So the way I can do a branching is I can have 3 carbons and I can branch out here. That's possible. So when I do this, I would have, this is a methyl group, and I can do a double bond here because this compound is unsaturated, so I need to have a double bond here. So this carbon formed 2 bonds, so it can have 2 more hydrogens here. This guy has 4 bonds, there'll be no hydrogen here. This has only 1 bond, so I can add 3 hydrogens here. Right, so let's count. We have 4 carbons and 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens, so I'm good. The name is, the longest possible chain here is this one, and I'm going to number it from this side because that's going to give the double bond the least possible number. So 3 carbons in the chain, so I know that it's going to be a prop, and it's going to be an in because there's a double bond. So in this case, even if the double bond was here, it would always be 1 in. It's always going to be in. So you can choose to say prop 1 in, Or you can just say propene. That's okay, because there's only one possible position of the double bond to be, and it's always going to be in the first carbon. But we have a branching on the second carbon. This is a methyl group on the second carbon, so what I'm going to say is, what I'm going to say is 2-methyl prop-1-ane, or you can just say 2-methyl propene. Now you can also do cyclic compounds, and when you're doing cyclic compounds, you don't need to, for unsaturated compounds, you don't need the double bond. For cyclic, you don't need double bonds. Don't need double bonds. You'll see why. So I can do this. So this has 4 carbons, and they are a cycle. They form a cycle, so it's cyclic. And this carbon has formed 2 bonds, so I can add 2 hydrogens to it. Same here. I can add 2 hydrogens. So if you check it, you would have 4 carbons and 8 hydrogens. So you would call this cyclobutane. Notice you're saying butane because there is no double bond. So this also works. This is good. So these are the ways you can do it.